Here we'll find the equation of a line. We are asked to find the equation of a line that passes through the function y equals square root of x at x equals 1 and x equals 9. The formula for the equation of a line looks like this. We'll say y equals m times x minus x1 plus y1. The x1 is the first x value, the y1 is the first y value, and the m is the average rate of change. Let's remind ourselves also to find the average rate of change, we take y2 minus y1 over x2 minus x1. Therefore, in order to find the equation of the line, we must first find the average rate of change. Now, in order to find the average rate of change, we must get two x's and two y's. You may be able to see that we do have two x's already. Therefore, our first order of business is to get the two y's that go with them. My first x, which I'll call x1, is equal to 1, and my second x, which I'll call x2, is equal to 9. The y that goes with them, y1, will equal square root of x. So we'll place the 1 that we started with in this position that I'm boxing in where x is. So y1 will equal square root of 1, and then y2 will equal square root of 9. The square root of 1 is still 1, and the square root of 9 is 3. Therefore, we'll write x1 is 1, y1 is also 1, x2 is 9, and y2 is 3. Now that I have the two x's and y's, I can get the average rate of change. We remind ourselves that the average rate of change is equal to y2 minus y1 over x2 minus x1. y2 was 3, that will go in the first position. y1 is equal to 1, that will go in the second position. Therefore, on the top, I have 3 minus 1. On the bottom, I have x2 equals 9, x1 equals 1, so I will say 9 minus 1 on the bottom. On the top, 3 minus 1 gives 2. On the bottom, 9 minus 1 gives 8. 2 divided by 8 reduces to lowest terms 1/4. This will be my average rate of change, and I will label this with the letter m as we have in the equation. Now that I have my m, I can use my equation of the line and fill in the m in the first position. I can fill in the x1 and the y1 in the other positions. I've boxed in the x1 and y1 in red, and we will place them where I've put the red underlines in the equation. I'll go to a new page to do that. Where the m is located in this equation, we will place the 1/4. In the parentheses, that says x minus x1, we'll let the first x stay as an x, but then replace the x1 with the number that x1 is equal to. That's 1. Then we'll say plus y1. y1, it turns out, is also 1. Therefore, we'll place 1 in the final position also. The important thing here is that the x and the y that are not labeled x1 and y1, we will leave those as letters, but the x1 and y1 will be replaced with numbers. So be on the lookout for the difference between regular x and x1. Now that we've replaced all of the numbers, we will now simplify this by distributing the 1/4 to the x and the -1. If we multiply 1/4 times x, we'll have 1/4 x, and then 1/4 times -1 gives -1/4 plus 1. We'll say y equals that. Now, we can combine the -1/4 and the 1, but we're going to have to get a common denominator in order to do so. Since we have a denominator of 4 in the fraction we're trying to add, we will multiply on the top and bottom by 4. That will give us our common denominator. So therefore, we'll have y equals 1/4 x minus 1/4 plus 1 times 4 on the top would give 4, and on the bottom we'll just have another 4. This will allow us to combine these fractions. We'll have negative 1/4 plus 4/4, and then if we take negative 1 plus 4, we'll get positive 3/4. Therefore, our equation of the line is 1/4 x plus 3/4. So now, through finding x and y at both of the points we started with, finding the average rate of change, and then plugging everything we know into this equation of the line, we have found the correct equation between the 2 points. Thank you for watching. We'll see you again soon.